Welcome to Math with Mr. J. In this video, I'm going to cover how to convert between scientific notation and standard form. We will start by writing numbers in scientific notation, so converting standard form to scientific notation. Then I'll give you some practice problems to go through to see if you have it down. After that, we will move on to going from scientific notation to standard form. Once we go through how to do that, I'll give you some more practice problems to see if you have that down. Let's jump into writing numbers in scientific notation, and we'll start with large numbers, then move to small numbers. Now remember, scientific notation is a way for us to write really large numbers or really small numbers in a shorter, more condensed way. This helps make really large and really small numbers more manageable and easier to work with. For example, we have this really large number right here. This number goes to the trillions, and this is actually the number of miles light travels in 1 year. This is what we call a light year, which a light year is, again, the distance light travels in 1 year. Light years are used to measure very far distances in space. Now, working with numbers like this and writing numbers like this can be difficult, tedious, and take up a lot of space with all of those digits, all of those zeros. So we use scientific notation to condense them, to write them in a simpler form. Here's that number in scientific notation. So we can see how that number was condensed. It was shortened, but it's still equal to the number above. Now, when it comes to scientific notation, we're going to have a number that is greater than or equal to 1, but less than 10. And we're going to multiply that by a power of 10. Now, keep in mind, these are equal. 5.88 times 10 to the power of 12. So the scientific notation is equal to this number. So how do we go from this to this? Well, let's jump into our examples, starting with number 1, where we have 6,500. We're going to start smaller than the example above and work our way up. Now, basically, all we need to do here is move the decimal to the right of the first non-zero digit, so anything 1 through 9. And we count how many places the decimal moved. That will give us everything we need to write the number in scientific notation. So looking at this number and reading it from left to right, what's the first non-zero digit that we come across? Well, this 6 right here. So we need the decimal to the right of that. So right here in between the 6 and the 5. So let's move the decimal there. And the decimal comes after the ones place, to the right of the ones place. Basically, just put it after a whole number. So right here. And we need to move it once, twice, 3 times. So the decimal is going to go right here. So what we do, we write 6.5. Now we need to leave any zeros to the right off. We don't need those. We are condensing this number. And then we need to multiply this by a power of 10. Now we need an exponent. And our exponent is going to be how many places the decimal moved. And that was 3. So we need an exponent of 3 here. And this is our scientific notation. 6.5 times 10 to the power of 3. This is equal to 6,500. We have a number greater than or equal to 1, but less than 10, times a power of 10. Now, I do want to mention before moving on to number 2 that when we have scientific notation with a positive exponent, we are working with large numbers. When we have a negative exponent, we are working with really small numbers, and we will get to those next. Let's move on to number 2, where we have 19 million. So we need to start by moving the decimal to the right of the first non-zero digit. So looking from left to right here, our first non-zero digit is this 1. So we need to move the decimal right here in between the 1 and the 9. The decimal goes right here, and we need to move it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. Now we can write this in scientific notation. So we write 1.9 and we leave all of the zeros to the right off times, and now we need our power of 10. So how many places did the decimal move? Well, 7. So that is our exponent. And this is our scientific notation for number 2. 1.9 times 10 to the power of 7. Moving on to number 3, let's write this number in scientific notation. So we need to find that first non-zero digit, which that's going to be this 7 right here. And we need the decimal to the right of that. So in between the 7 and the 0. The decimal goes right here. And now let's move it. So we have once, twice, 3 times, 4, 5, 6, 7, 8, 9, and 10. So we need to write this as 7.082, and then we can leave all of those zeros to the right off, times our power of 10, which is going to be 10 to the power of 10 since we moved that decimal 10 times. And this is our scientific notation. 7.082 times 10 to the power of 10. Lastly, let's move on to number 4. So let's find that first non-zero digit, which is going to be this 4 right here, and we need to move the decimal to the right of that. The decimal goes right here after the ones place, after the whole number, and now let's move it. And since we have a lot of zeros here, one thing we can do is move the decimal in groups of 3. We don't have to do it this way, but I at least wanted to show this. It can be helpful and quicker when working with numbers with a lot of zeros. For example, 3, 6, 9, 12, 13, and 14. So we can write this as 4, and then we leave all of those zeros to the right off, and we just have a 4 here, a whole number. We don't have any decimal digits to include. We just have zeros to the right, so this is fine. Times 10 to the power of 14. And this is our scientific notation. So there you have it. There's how to write large numbers in scientific notation. Let's move on to writing small numbers in scientific notation. Now let's take a look at writing small numbers in scientific notation. For example, we have this number right here. Let's say that this is the diameter of a cell, so 0.000072 meters. So we have a measurement of something that is very small here. So here is that number written in scientific notation. We have a number to start with right here, 7.2, that is greater than or equal to 1, but less than 10 times a power of 10. And this is equal to the number above. So how do we go from this to this? Well, let's jump into our examples, starting with number 1. Now this is going to be very similar to when we write large numbers in scientific notation. We move the decimal to the right of the first non-zero digit, so anything 1 through 9, and we count how many places the decimal moved. That will give us what we need to write something in scientific notation. With small numbers, though, we will move the decimal to the right and use negative exponents, which we will talk about here shortly. So those two things do differ from when we have large numbers. So looking at our number here, we are reading it from left to right. What's the first non-zero digit that we come across? Well, it's going to be this one right here. So we need to move the decimal to the right of that one. So we need to move the decimal once, twice, three times, four times, five times, and six times. So we moved the decimal 6 places to the right. So what we do now, we write 1 and we just have a whole number here. We don't have any decimal digits for this one, so we just have 1. And all of those zeros to the left of 1 we leave off. We don't need those. And then we multiply that by a power of 10. So 1 times 10, and now we need an exponent. So what power of 10 here? Our exponent is going to be how many places we moved the decimal. And since we are working with a small number here, this is going to be a negative exponent. Well, we moved the decimal 6 places, so our exponent here is going to be negative 6. So we have 1 times 10 to the power of negative 6. And that's our scientific notation. Now we're using a negative exponent here. We want to multiply by that negative exponent because this is a way to represent division or taking a fraction of something, which gives us that smaller number. Remember, a negative exponent just means we can turn it into a fraction with a numerator of 1 with a positive exponent in the denominator. So 10 to the power of negative 6, let me write this up here. So 10 to the power of negative 6 equals 1 over 10 to the power of positive 6. And 10 to the power of 6 equals 1 million. So this is actually 1 over 1 million, 1 millionth. So looking at our scientific notation, we have 1 times 10 to the power of negative 6, which this just means 1 times 1 over 10 to the power of 6, or 1 times 1 over 1 million, which all of this is the same as dividing by 1 million. Multiplying by 1 over 1 million is the same as dividing by 1 million. And that gives us our original decimal. So with small numbers, we use a negative exponent because that's going to give us those small numbers. Keep in mind, this is equal to this. Let's move on to number 2, and we need to start by finding the first non-zero digit. So looking from left to right, this 3 is the first non-zero digit. So we need to move the decimal to the right of that. So we need to move it once, twice, 3 times, 4 times, 5 times. So the decimal goes right here. So all we need to do now is write 3.8 times, and now we need our power of 10. So our exponent is going to be how many places we moved the decimal. That was 5. And we're working with a small number here, so we need a negative. So this is 10 to the power of negative 5. So for our scientific notation, we have 3.8 times 10 to the power of negative 5. Let's move on to number 3, and we can start by looking at this number from left to right and finding that first non-zero digit. So what's the first non-zero digit that we come across? Well, this 4 right here. So we need to put the decimal to the right of that. Let's move the decimal. So once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. So the decimal is to the right of that first non-zero digit now. So we write out 4.025. And now we need to multiply that by a power of 10. So times 10 to the power of, well, how many places did we move the decimal? 9. So we need a negative 9 here for our exponent. So 4.025 times 10 to the power of negative 9, and that's our scientific notation. Lastly, moving on to number 4, we need to start by finding that first non-zero digit. So looking from left to right, that's going to be this 9 right here. So let's move the decimal to the right of that. We need to move the decimal once, twice, 3 times, 4 times, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 9.7 times 10 to the power of negative 13. And that's our scientific notation. So there's how to write small numbers in scientific notation. And now that we've covered large and small numbers, let's try some practice problems. So here are our practice problems. Have a piece of paper and pencil ready, and you can try these on your own. Feel free to pause the video and give these a try, or let the video play and I'll give you 3 minutes. Whenever you're ready, click ahead to the answers and see how you did. So write each of these in scientific notation. Go ahead and start. Okay, so let's take a look at the answers here and see how you did. So here are our answers. For number 1, we have 1 times 10 to the power of 7. For number 2, we have 8.2 times 10 to the power of negative 5. For number 3, 2.095 times 10 to the power of 11. For number 4, 5 times 10 to the power of negative 8. For number 5, 9.94 times 10 to the power of negative 9. And lastly, for number 6, 6.73 times 10 to the power of 14. So there's how to convert standard form to scientific notation. Let's move to converting scientific notation to standard form. Now let's take a look at going from scientific notation to standard form. We will start with 3 examples where we will be working with positive exponents, so large numbers. Then we will move to 3 examples of negative exponents, so small numbers. And then we will end with some practice problems that you can try on your own. So again, we're going to go from scientific notation to standard form, which standard form is basically how we typically think of numbers and write numbers. Let's jump into our examples, starting with number 1, where we have 9.3 times 10 to the 7th power. And this is actually about the distance in miles that the Earth is from the Sun. So we have a large number here, a really far distance. Let's write this in standard form. All we need to do here is check the exponent and move the decimal. So let's see what this looks like. We'll start by writing 9.3 off to the side. So we're just writing whatever's to the left of the multiplication sign. Now we need to check the exponent. For number 1, the exponent is 7. That tells us that we need to move the decimal 7 places. But which way? Do we move it left or right? Remember, when we have a positive exponent, we know that we are working with a large number. When we have a negative exponent, we know that we are working with a small number. Well, we have a positive exponent here, so we have a large number. That means we are going to move the decimal to the right. We are multiplying 9.3 by 10 to the 7th power. So 9.3 is going to be increasing in value. So let's move this decimal 7 places to the right. 1, 2, 3, 4, 5, 6, 7. And now we can fill those gaps, those places, with zeros. So we need a 0 here, 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 and here. And that's our standard form. But let's rewrite this a little neater without the decimal movement underneath. So we have 93 and then 1, 2, 3, 4, 5, 6 zeros. So 1, 2, 3, 4, 5, 6, and then we can put in the commas. So a comma here and here. So we have 93 million. And we are done. That's our standard form. So all we need to do here is check the exponent and move the decimal. Let's move on to number 2, where we have 5 times 10 to the 10th power. So let's write 5 off to the side. And the decimal comes after a whole number, after the ones place. So the decimal is right here, and we need to move it. Well, our exponent is 10, a positive 10. 5 is increasing in value here, so we have a large number. We need to move the decimal to the right. So let's move it to the right 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we can fill with zeros here. And that's our standard form. So let's rewrite this. We have 5 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we can put in the commas. So a comma right here, and right here. So we have 50 billion for number 2. Lastly, let's move on to number 3, where we have 6.802 times 10 to the ninth power. Let's write 6.802 off to the side here. So 6.802. And looking at the exponent, we have a 9, a positive 9. So we're working with a large number here. We need to move the decimal 9 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And fill with zeros here. And that is our standard form. But let's rewrite this. We have 6.802 and then 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. Then we can put in the commas. So a comma right here, and right here. So 6,802,000,000. So there's our positive exponent examples. Let's move on to our negative exponent examples. Here are our negative exponent examples. Let's jump into number 1, where we have 8 times 10 to the negative 6th power. Let's write this in standard form. We'll start by writing 8 off to the side. So we're taking what's to the left of the multiplication sign. So we have 8, and then we need to include the decimal, which comes after a whole number. So to the right of the ones place. So right here. Now we need to take a look at our exponent, which is negative 6. That tells us we moved the decimal 6 places. But which way? Do we move it left or right? Just remember, when we have a positive exponent, we know that we are working with a large number. When we have a negative exponent, we know that we are working with a small number. Well, we have a negative exponent here, so we are working with a small number. That means we move the decimal to the left. We are multiplying 8 by 10 to the negative 6th power. 8 is going to be decreasing in value here. So let's move the decimal 6 places to the left. So 1, 2, 3, 4, 5, 6. And then we can fill those gaps, those places, with zeros. So a 0 here, 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 and here. And that's our standard form. But let's rewrite this a little neater without the decimal movement underneath. We will start with a 0, and then the decimal, and then 1, 2, 3, 4, 5 zeros, and then the 8. So 1, 2, 3, 4, 5 zeros, and then the 8. And we're done. That's our standard form for number 1. Let's move on to number 2, where we have 2.74 times 10 to the negative 8th power. Let's start by writing 2.74 off to the side here. And then taking a look at the exponent, we have negative 8. Since we have a negative exponent, that tells us we have a small number here. And we need to move the decimal to the left. And we're going to move it to the left 8 places. So 1, 2, 3, 4, 5, 6, 7, 8. And now we can fill those places with zeros. And that is our standard form. So let's rewrite this. So 0, then the decimal. Then we need 1, 2, 3, 4, 5, 6, 7 zeros, and then 274. So 1, 2, 3, 4, 5, 6, 7, and then 274. And that's our standard form for number 2. Lastly, let's move on to number 3, where we have 1.6 times 10 to the negative 11th power. Let's start with 1.6 off to the side here. So 1.6 0.6. And then we have an exponent of negative 11. So a negative exponent here, that tells us we have a small number and we need to move the decimal to the left. And we're moving it to the left 11 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now we need some zeros. So let's fill those gaps, those places, and that will give us our standard form here. And let's rewrite this. So we have 0 and then the decimal. Then we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros, and then 1, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and those are all of our zeros. Then we need 1, 6. And that's our standard form for number 3. So there's how to go from scientific notation to standard form. Now it's time to try some practice problems. Here are 4 practice problems that you can try on your own. So have paper and a pencil ready. Feel free to pause the video and work through these, or let the video play and I'll give you 2 minutes. Jump ahead to the answers whenever you're ready. Go ahead and start. Okay, so let's take a look at the answers here and see how you did. So here are the answers for numbers 1 through 4. For number 1, we had a positive exponent of 8. So we needed to move the decimal 8 places to the right. For number 2, we had an exponent of negative 5. So we needed to move the decimal 5 places to the left. For number 3, we had an exponent of negative 9. So we needed to move the decimal 9 places to the left. And then lastly, for number 4, we had a positive exponent of 11. So we needed to move the decimal 11 places to the right. Feel free to pause the video here and take more time to check your work. So there you have it. There's how to convert between scientific notation and standard form. I hope that helped. Thanks so much for watching. Until next time, peace.